Okay. Good evening, students. Whether my voice is clear and the screen is visible? Can anyone?
Yes, sir.
Okay.
Yes, sir.
Today we are going to see the lecture number 22. It is split phase induction motor. Okay, split phase induction motor. So this is one of the first starting methods in single phase induction motor. Okay, yesterday class I had clearly mentioned there are 5 starting methods. Okay, there are 5 starting methods are available. The first one, it will be split phase induction motor. Second one, capacitor start induction motor. Third one, capacitor start, capacitor run induction motor. Fourth one, permanent split capacitor. Fifth one, shaded pole motor. Okay, shaded pole induction motor. Now today class we are going to see the split phase induction motor. This is my first method. Okay, split phase induction motor. This split phase induction motor, it is a type of, it is a type as well as a starting method of single phase induction motor. Okay, and this induction motor, it is having two windings. Okay, it is having two windings. One is main winding, another one is auxiliary winding. Okay, now first one, split phase induction motor. The other name of split phase induction motor is resistance start induction motor. Okay, the other name of split phase induction motor is called as resistance start induction motor. You see the diagram, circuit diagram. Okay, this circuit diagram, we are giving a single phase voltage. Okay, so this is the single phase voltage. Maybe you can say it will be 220 volt. Okay, and 50 hertz supply. 50 hertz. This is positive, negative, neutral, negative. When you apply the voltage, the current flows in the winding. Okay, there are two windings are available in single phase. One is main winding, another one called as starting winding. What is another name of starting winding? It is auxiliary. Okay, auxiliary winding, that is starting winding. So these two windings are connected in parallel. Okay, so these two windings are connected in parallel. Okay, so the current, you see the current, this is my total current. It will be enter into the junction point. Okay, it is enter into the junction, but this is my junction point, and once it enter, the current will be equally distributed to these two windings. Okay, so whatever the current is entering into the main winding, that is Im. Okay, Im stands for the current flows through main winding. Please 1 second. The current flows through main winding. The current flows through the main winding, that is nothing but first current. Okay, the current flows in the main winding called Im. Okay, and the current entering into the starting winding is called Ist. Okay, so the Im stands for the current flowing in the main winding, and IST stands for the current flowing in the starting winding. Okay, and this starting winding is connected with a centrifugal switch. Okay, centrifugal switch. Okay, so the other end of starting centrifugal switch is connected to the main winding. Are you understand? Okay, so in split phase induction motor there are only three parts are available. One is main winding, another one, this is my first part. Okay, this is my first part, and second part is starting winding, and third part is centrifugal switch. Okay, and this is one of the simplest arrangement to set the rotating magnetic field. Okay, normally in main winding and starting winding there are two fluxes are produced. Okay, there are two fluxes are produced. Okay, here one flux is produced, that is nothing but phi m. Okay, another flux is produced in starting winding, that is phi s t. Okay, that is nothing but phi s t. Okay, so there are two fluxes are produced. Okay, how? Because you know already familiar about a single phase induction motor is not self start. Okay, so to make the induction motor to self start, we are going for this starting methodology. Okay, so that's what we are having it two windings. Otherwise, if only one winding is there, definitely the machine not start to run. Okay, so what we are going to do here, once the flux is produced, okay, in the starting winding as well as the main winding, the switch you have to close. Okay, so once you close the switch, okay, see the current, starting current flows in the rotor. Okay, it flows in the rotor. Okay, you see this is a circle, it is a rotor. Okay, flows in the rotor. So once the current induced in the rotor, immediately the rotor will start. Okay, the rotor will start running. Will start run. When it will start run? When is your centrifugal switch is closed. Okay, when is your centrifugal switch is closed, then your machine will start running it. Okay, but you can't keep the switch, it should be in closed position. Okay, so what we have to do, because to continue the machine to run continuously, okay, so for during that time you have to remove the switch. That is nothing but you have to close this centrifugal, open the centrifugal switch. So once you open the centrifugal switch, automatically there is no current. Okay, there is no current will be induced in starting winding. Then the machine will start running continuously. Okay, it start running continuously. Okay, so this is the point you have to note down. Okay, this is one of the important point. Okay, when your switch will be open, automatically the starting winding not getting any current. Okay, once the current is not entering in the starting winding, so automatically there is no flux. Once the flux not produced, then the machine will start running continuously by using only one flux. Okay, the main purpose of starting winding, it is only for initial stage we are using it. Okay, we are using it. Okay, and the value, okay, why we are saying this is resistant start induction motor means, here you see this is a winding arrangement. Okay, normally the winding means it will be like this. Okay, this is called winding, or we can say it will be a coil. It will be a coil. Okay, this winding consists of resistance and reactance. Okay, it's having resistance and reactance. The combination of these two, we have to say it is a winding. Are you understand? Okay, so the resistance will be connected in series with the winding. Here only it will be connected in series with this winding arrangement. Since the resistance value will be very low value in this arrangement, but the reactance value it is very high. That's what the winding is visible. Okay, the resistance is very low, that's what it is invisible. Okay. Okay, so in starting winding, the resistance value, it is the resistance low, but the reactance it is high. Okay, but in the main winding, the resistance high, reactance low. Okay, the resistance high, reactance low. Are you understand? Are you understand or not? Okay. Sorry, here it is a mistake. In main winding, it's having the low resistance. Okay, so it is low resistance and high reactance. But in the main winding, it is high resistance, low reactance, just opposite. Okay, so in main winding, the resistance value, okay, the resistance value is low, reactance is high. Okay, in starting winding, resistance high, reactance low. Okay, this X stands for reactance. Okay, X stands for reactance. And as well as the diameter, okay, the diameter of this both the windings, it's somewhat small. Okay, here the main winding, the diameter means this line, this one, you see this arrangement. Okay, it is very high. Okay, it is very high, the diameter in main winding is high. Okay, you see this diameter, it is very high, but here starting winding it is low. Okay, but starting winding it is low. Okay, why it is low means to reduce the amount of current at starting position. Okay, amount of current at starting position, and the current value which lags the voltage. Okay, the current value which lags the voltage. Okay, and here the winding designed for operation only for 75% of synchronous speed. Okay, only 75% of synchronous speed. Okay, so since these two windings are connected in parallel with the supply, because of the inductive nature, the main winding lags supply voltage by a large angle. Okay, you see this phasor diagram. Okay, this is the phasor diagram, and in the phasor diagram, this line called it as, okay, this is a phasor diagram. This line called it as voltage, and this is the Im, and it will be ist. Okay, the angle from V to Im it is phi m. The angle between ist to Im it is alpha. Okay, alpha is the angle between ist, starting current at starting winding, and main current at main winding. Okay, it is alpha. So the overall resultant will be a current. Okay, and these two lines we have to join. Okay, so here the current in the main winding Im lags behind the supply voltage V at an angle of 90 degree. Okay, it is 90 degree, and the current in the auxiliary winding, that is nothing but starting winding, ist, is approximately in phase with the line voltage I. Therefore there is a phasor difference between these two. Okay, it is alpha. The angle between these two, it is approximately, it is 30 degree. Okay, approximately it is 30 degree or 60 degree. Okay, the center point we have to mark it as 30 degree. Okay, the angle between Im to I it is 30, and I to ist it should be 30. So total you will get 60 degree. Okay, any doubts? Again I will explain. The split phase induction motor is nothing but it is a resistant start induction motor. It consists of two windings. One is starting winding, another one is main winding, and centrifugal switch. These are the three major parts are available in this system, and the starting winding and main winding are connected in parallel. Okay, are connected in parallel, and we have to give a single phase supply. and the resistance should be connected in series with both the windings. Okay, in series with both the windings. That's what I have drawn this diagram here. The value of resistance in main winding, okay, main winding, it is very low, but reactance it is high. Reactance it is high. But in terms of starting winding, the resistance is high, but the reactance is low. Okay, reactance is low. As well as the diameter, okay, the diameter of this main winding is higher, but compared to starting winding. Okay, compared to starting winding. Now the operation is very simple. If you apply the voltage, then the current flows in both the winding, then flux is produced. Okay, now during the time you have to close the switch. Once the switch is closed, immediately the motor, okay, will induce, okay, the induced EMF will be in the motor. Okay, the EMF will be induced in the rotor of an induction motor. Then the machine will start running. Okay, it will be start running slowly. Okay, so once it will be start running based upon your voltage applied, and after some time you have to release the centrifugal switch. We have to open the centrifugal switch. Once you open the centrifugal switch, so then there is no supply flowing in the starting winding arrangement. So therefore there is an absence of flux in the starting winding. Then by using only one flux produced in main winding, the machine starts running continuously. Okay, so this is the split phase induction motor. Any doubts? And here the motor will be gather the speed almost 75 to 80%. Okay, it will be gather the speed from 75% to 80%. Okay, 75 to 80% it will be get. Okay, and this auxiliary winding will be designed only for a short duration. Okay, only for short duration means it is normally 1 second or 1 minute, like that we have to. Okay, once you the auto transformer, if you vary the auto transformer till rated voltage, then immediately we have to release the switch. Once you release the switch, then the starting winding is absent. Okay, there is no purpose of for starting winding. Okay, by using the main winding itself, we have a make the machine to run. Okay, so that's what I'm telling. The starting winding is only for starting purpose. Okay, it is only for starting purpose. Any doubts? Any doubts, students? Have any doubts? Please give reply. Please give reply.
Yes, sir.
Okay. The theory which is just now I explained. Okay, so once your starting winding is in the circuit, and as a motor attain predetermined speed, the current in the relay, because it is automatic process, okay, the relay will be connected in the circuit, it will automatically starts decreasing. Once a relay is nothing but your centrifugal switch. Okay, that is nothing but relay. Once a relay open, the disconnect the auxiliary winding from the supply, then make the motor run on main winding only. Okay, so there are two windings are available. One is main, another one is auxiliary. That is nothing but starting. The starting winding is only for starting purpose. Okay, it's only for starting purpose. For running purpose, you have to use anyway, you have to use the main winding only. Okay, then this is the torque speed characteristics of split phase induction motor, and x-axis will be the speed, y-axis will be the torque. Okay, this is y-axis, this one will be a x-axis, and this is 0, this is ns. Ns will be the synchronous speed. Okay, you can mention it is 1430 rpm. Okay, 1430 rpm. Now The concept is here very simple. Okay, now please forget about the main winding and auxiliary winding. Okay, you are having only one winding is available. Okay, now the first stage, when you operate, okay, when your centrifugal switch is closed, so there are main winding and plus starting winding is nothing but auxiliary winding is available. Okay, now by using these two windings only, we are making the machine to start run. Okay, to start run. During that time, you see this red line. Okay, during that time, this red line, it start running it. Okay, when you vary the voltage, okay, parallelly you have to vary the voltage 0 to 230. Okay, when you vary the voltage, the speed value is also be keeps on increasing it. Okay, you see it will be keeps on increasing it, and then it will be achieve the target. Okay, the target is somewhat, the torque value is somewhat smaller. Okay, it is smaller. Okay, that is one of the advantage here. Okay, the main advantage is that it's having a low starting, it's having low starting torque and current. Okay, low starting torque and current. Okay, so this waveform will be shown. Okay, the value of the waveform, it will be vary. Okay, by using main and auxiliary winding. Okay, now if your centrifugal switch is open, okay, if this condition is only for centrifugal switch is closed, okay, then the motor is starts running slowly. Okay, now you have to make the motor to continuously to run. So what you have to do, you have to close, you have to open a centrifugal switch. Once you open it, there will be only main winding will get supply. Okay, starting winding will be not getting any supply, so it will be absent there. So by using only one main winding, the machine, it will be achieving this torque value. You see, it is starting from 0. Okay, it is slowly, it will be increasing it, and then it is reaching the ns point. Okay, this is the curve. Actually the curve is should always starts from 0 till it is ns. Okay, when it will be ns, when switch is open. Okay, so when it will be open means, you see this point, the topmost point, okay, the peak point of the red color line, it is main plus auxiliary winding. If you draw the line, this line will touch the particular point of your main winding line. Okay, this point will call it as switch is open. Okay, so during the time when your switch is open, you can get the speed value, it is somewhat 1000 rpm, somewhat 1000 rpm you will get it. Okay, then normally the machine will start running very slowly. Okay, this is the torque speed characteristics of split phase induction motor. Okay, here N0 is a point at which a centrifugal switch operates. Okay, the starting torque of the resistance start motor, it is one more question, it is 1.5 times of full load torque. The maximum torque, okay, this is the maximum torque, this line, this line, it is maximum torque, TM. Okay, maximum torque, it is 2.5 times of full load torque. Okay, full load torque. The starting current of the motor is also 7 to 8 times of full load value. Okay, the starting current of the motor is high, about 7 to 8 times of full load value. The direction of the starter can be reversed by reversing the line connections, either main winding or starting winding. Okay, the reversal of the motor is also possible at standstill conditions. Standstill means it is in Not running condition, when the supply is on but the motor not running it, that is nothing but standstill condition. Advantages: this type of motors are very cheap and are suitable for easily starting loads where the frequency of the starting is limited. Where the frequency of starting is limited. Disadvantages: this type of motor is not used for drives which require more than 1 kilowatt because we are getting very low starting torque, right? Okay, because of this low starting torque, it is one of the disadvantage. You can't operate more than 1 kilowatt machine. That's what it is very cheap. Applications: since it is low starting current and moderate high starting torque, these motors are used in fans, blowers, centrifugal switches, washing machines, grinder, lathe, air conditioners, fan, etc. And it is also available in the range from 1 bar 20 to 1 bar 2 kilowatt, that is 0.5 kilowatt, 0.5 kilowatt. Okay, so you should understand this concept. The split phase induction motor, we are giving a single phase supply you are giving it. Okay, it is having a 2 winding. One winding means it is having high diameter, okay, and another winding gets connected in parallel, it is low diameter, and this low diameter is nothing but starting winding which is connected with a switch. Okay, it's connected with a switch which is connected, and then it is connected to the motor. This is a rotor arrangement. Okay. This is the rotor arrangement, and this is nothing but main winding. Okay, the resistance value will be available in main winding, which is high or low. Can anyone? The resistance value. Hello? Low. Okay, the resistance value available in the main winding, it is low, but in starting winding it is high. What about the reactance? In main winding, the reactance it is high. Here reactance will be low. You see the shape. Okay, this is the inductive nature. Okay, because it is inductive nature, because here we are not having any capacitor. Okay, the basic property of the inductance, it is the inductance means L. Okay, it is the passive element, which is the passive element. It is the property to store energy in magnetic field. Okay, it's having the property to store energy in the magnetic field. Okay, so the formula for voltage, V equal to L into di by dt. Okay, differentiation is available. In terms of current, I equal to 1 by L integral of V dt. Okay, this is very important to note down. Okay, and the inductance which is applicable only to the lagging perfector, it is lagging. Okay, lagging perfector, it is lagging perfector here. And another concept in inductor, this is the inductor. These concepts you already studied in your basic electrical. If you apply the voltage in the inductor, the current flows in the inductor. Once the current flows, there will be a flux is produced. Okay, the same principle only. If you apply the voltage, the current flows in the circuit, then two fluxes are produced in this winding. One flux will be the main winding, another flux will be the in starting winding. Okay, when the switch is closed, then the motor will start. Okay, it start running slowly, and you have to vary the voltage till 220 rated voltage in auto transformer. Once you achieve the rated voltage, okay, then at a particular moment you have to open a switch. The centrifugal switch should be open. Once centrifugal switch should be open, there is no supply to this starting winding, so it's automatically disconnected. Okay, once that winding is disconnected, then by using one flux, okay, this flux will make the machine to run continuously, okay, to run continuously at a particular rated speed. Okay, any doubts? This is known as split phase induction motor. The other name of split phase induction motor, it is the resistance start induction motor. Okay, the other name of split phase induction motor is resistance start induction motor, because the resistance parameter which plays a major role in both the main winding and auxiliary winding. Okay, since the resistance will be series with inductance. Okay, series with inductance both in main and auxiliary. Okay, any doubts? Have any doubts, students? If you have doubts, please ask me. Have any doubts?